2016 paper 1 question 2. We're given arithmetic sequence, and then 2.1 says write down the fourth term of the sequence. So in order to do that, we must find the formula first. So we can see here, it's minus 3 minus 1, right, which gives us negative 4. 1 minus 5, which gives us negative 4. So it's an arithmetic, which means we have a common first difference. So this is our A and this is our D. So the formula will be Tn is equals to A plus D n minus 1. So our A is negative 4 plus our D is, our A is 5 plus our D, which is negative 4 n minus 1. So multiply out to be 4, 5 minus 4 n minus 1. So this is our formula for Tn. So now to calculate T4, you'll just say T4 is equals to 5 minus 4, 4 minus 1. Put this into a calculator. So you have 5 minus 4, 4 minus 1, which gives us negative 7. So that will be our T4, negative 7. So that will be the answer to question 2.1. And then moving on to question 2.2, they say calculate the number of terms in the sequence. So the number of terms in the sequence, in order to do that, we know that the last term of this sequence is negative 87. So we have to find out what our n is here, right? So in order to do that, continue this side. This is 2.2. We've got Tn is equals to 5 minus 4 n minus 1. Tn will be equal to 5 minus 4 n minus 1 is equals to negative 87. I'm going to solve for n. So I've got 5, got to multiply n, minus 4n multiply n plus 4 is equals to negative 87. And then 5 plus 4 is 9, so I've got 9 minus 4n is equals to negative 87. I'm going to bring my 4n to this side, so it will be positive 4n. 87 to this side, so it will be 9 plus 87. So 9 plus 87 gives us 9 plus 87 gives us 96. 96 is equal to 4n. Then to solve for n, divide by 4, divide by 4. So n will be equal to 24. So 96 divided by 4 gives us 24. So our n is 24. So that's our answer. So the number of terms in the sequence will be 24 terms. Alright, cool. Now, they say, question 2.3 says calculate the sum of all the negative numbers in the sequence, right? So since these are the only two positive numbers we have, right, and starting from negative 3, we have what? We have negative numbers, right? They want us to calculate all the numbers that starting from negative 3, right? So if I write down these numbers, so I have 5, 1, negative 3, negative 11, negative 7, and then negative 11, then it continues up to negative 87, right? So obviously we said from here to here we have what? 24 numbers, 24 terms. So from here, if we skip these two, right, From here to here, we will have how many terms? We'll have 22 terms, right? So if you want the sum of the 22 terms, we no longer treat this as our first term, but the -3 as our first term, and our d remains the same because this will still give us -4, -4. So this basically is our new pattern. So Sn is equals to n over 2a plus d n minus 1. This is your formula for the series, for the summation. So I'm going to continue this side. So Sn will be equal to, how many terms do I have? I have 22 now. So it will be 22 over 2. Our a is what now? It's -3, plus our d stays the same, and then 22 minus 1. And then we solve for our sum of the 22 numbers. So we'll have 22 divided by 2, and then 2 minus 3 minus 4, 22 minus 1, and then our answer is S22 will be equal to minus 990. So that will be the sum of the negative numbers. So basically, you start counting from the -3 and you ignore these two this side. Alright, cool. Moving on to question 2.4. So question 2.4 says calculate the sum. Consider the sequence 5, 1, -3, -387, and then it ends at -4,187. Let's say determine the number of terms in the sequence that will be divisible by 5. So in order to do that, I'm just going to write down the pattern here quickly. So the pattern will be 5, 1, -3, -7, -11, -15, -19, -23, -27, -31, -35, -39, and 43. Right, so if you were to write down the pattern, just these few numbers, this is what you'll get, right? Now looking at this, the numbers that are divisible by 5 here, we've got 5, we've got -15, we've got -35, right? So we have what? 5, -15, and -35. So if we look at this, this forms a pattern in itself where your d is -15 minus 5, -20, and then this gives you -20 as well. So we can find a pattern of for the numbers that are divisible by 5. So the pattern for the numbers that are divisible by 5 will be Tn is equals to, the formula will be 5, your d will be -20, and then n minus 1. So this is the formula for the numbers that are divisible by 5. So if I put T1, 1 here, the first number that will be divisible by 5 will be 5. T2 will be -3. T3, the third number to be divisible by 5 will be -35, and so on, right? So this is what we get. So these numbers here, this pattern continues up to what? -4187, right? And we know that the number that comes before this, that's divisible by 5. So if I keep counting, I'll get the number that is close, the first number that is divisible by 5 that's close to this number here will be -4185. Because if I keep counting, I'll say -4185, -4186, negative 4187. So the last number to be divisible by 5 is negative 4185, right? So that's the last number. So if I keep counting here, this will be negative 4185, will be somewhere here. Now I have to find what number this will be, right? So the last one, I'll say Tn 5 minus 20 n minus 1 will be equal to negative 4185, right? So I'm going to solve for n here. So I have 5 minus 20n, 5 minus 20n plus 20 will be equal to negative 4185. Then this will give us 25 minus 20n is equal to negative 4185. And then this, I'm going to bring my negative 20n this side, becomes positive, and then 25 plus 4185. This will give us 4,200. You can use your calculator. And then we divide both sides by 20, and we get that n will be equal to 210. So the number of terms that are divisible by 5 between the 5 and the 5187, 4187 is 210. So that's the final answer. Alright, cool.